Um, I was talking to Megan. I had a question about 3B and 3C. You remember how to do that, Cambria?
Can you hear me?
Yeah.
Yes.
Oh, okay. Goodness, it wasn't working. I'm like over here talking and no one's listening. Okay, hold on. Okay, what did you say?
We were just kind of reviewing problems 3B and 3C. I was just kind of confused about them, about what we like exactly how the formula is to find it.
Okay. Hold on. My computer shut down for some reason, so I'm trying to get everything back up.
On the answer key, it says for 3B, it's 10 minus 5 multiplied by 0.25335.
Okay, so is that 2 point? That's from the applet, right? You put that in the.
I think that's when we did that like chart, and like it was the probability, and then you like take the value and like multiply it by the probability. Do you remember that?
Yeah.
The
Yeah.
chart. I don't remember. I guess where do they find that 0.25335 from?
Let me see if I can pull it up. Aha. Okay, it was like the one chart where it's like a four-sided dice has four possible outcomes. And then it's the value times the proportion. So the chances of getting 1 is 1 out of 4, which is 0.25. And then you multiply it by,
Yeah, I remember doing that.
and then after you do that, you like multiply. You get like the sum variance.
Do you get it, Chase?
No. Number 5. I don't get 3B.
Why is this being so stupid?
I read this in the car last night, so it might not have been the best studying. So I'm trying to remember if it said anything about how to get that in there. Okay.
I'm just trying to think because one of the equations to get the z-score is the sample mean minus the mu divided by the standard deviation
Uh-huh.
divided by the square root of n. But
So,
if we apply that to that, then what would the sample mean be? Or is that same as the 10?
so it looks like they're subtracting the standard deviation from the mean, and then I wonder if what they're multiplying it by is just reversing the um, division. Like if that's the standard deviation divided by the square root or something. How did you do that one last night?
Um,
I'm gonna be honest, I'm like so confused on this lesson.
hold on. Wait, are you asking about B or C, Chase? C?
Well, B, but I have a question about C too.
When is our test for this class?
Wednesday? I can tell you what A is.
Yeah, I can too.
Um, my question. No, maybe not.
Okay, so I think I can figure out. So C, um, take um, 18.5.
Where does the 0.2335 come from?
I asked that like 10 minutes ago.
Oh, that's what we're looking for? I thought you were looking for the equation.
Well, I want to know how to do it all.
Oh. I don't know where it comes from.
Well, what'd you do last night?
I was confused. What did you do last night?
Well, I tried to work it out as best I could, and I thought we'd talk about it. Hopefully you guys could help me with it.
False hope, my love. At least for me.
Okay, I know how to do C. I'm still confused about B, though.
I don't know where.
See, I just don't get where they got that equation from. Because
See,
that's the mean minus the
at
standard.
the top is different.
What?
The equation at the top in like the instructions is different.
What instructions are you talking about?
Right under. Oh, I'm totally looking at this the wrong way. Just ignore me. It's in number 2. It says, "What is the z-square formula for the sample mean?" But that's different.
That's the z-score, not
I know,
finding.
that's different. I know, that's different. That's what I just said.
Because I put 0.4 in the norm, the probability applet, and it comes with 0.842, so I don't know where 2 5's coming from.
Yeah, that's what I was thinking too. Because I know that, I understand the 10 minus 5, but the 0.25.
Where'd you get the 10 minus, like, what does that have to do with finding the 40th percentile?
Because I think it goes back to, like, the sample population and the probability of, like, something landing, or, like, something being picked. But I could be totally wrong.
Chase, did you just get a text from Pizza Pie Cafe?
Yeah.
I signed you up last night.
Okay, so I'm in back in lesson 5. It says calculating percentiles using normal distribution. It says, for example, the 25th percentile is a number in data set that is greater than or equal to 25%. Let me try something. No. Okay. Of all the values in the data set. We can find the values of percentiles for normal distribution by using the applet to calculate z-score corresponding to a specified area and then plugging that z-score into our z-score equation and solving for x. The following instruction shows how to find the 90th percentile. Okay, hold on a second. Yeah, I don't know.
Yeah, I don't know.
I wonder if that equation is just done wrong.
That's what I was just thinking, because
I don't remember ever subtracting the standard deviation from the mean. It's like that I don't know where they get that. Because it says in lesson 5,
What are you doing? What are you doing? Who's dog? Okay.
are you flipping us off?
no,
Answer.
I'm going to say they did that equation wrong because I'm not finding it.
Yeah, I can't find it in anything.
We've spent like 20 minutes just staring at it. Okay, so let's go to part 2 then. Alright, so suppose pair computing sold an average of the mean is 45 p phones per minute in 2011. Yes, that means they sold 23,602,000 p phones in 2011 with a standard deviation of 10. And they looked at their p phone sales data and determined that they are normally distributed. Samples of size n equals 4 are taken from the normally distributed 2011 sales. What is the shape of the distribution of x, of the value?
I'm guessing it would be normal.
Yes, the parent would be normal.
Mhm.
And that should work for number 5 too.
Yeah.
Yeah.
Okay. 6. A sample of size n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed sample mean is less than 40?
Okay. So the average is 45.
So that would be like, in the 6895 one, that would be about 68%. But
It'd be a little bit more than that, wouldn't it? Because it's 5 numbers away.
oh, okay. I read it wrong.
So let's see what happens if we put -1 in the applet, just to see. On the answer key, it does say 0.1587. That's what the normal probability applet gives you for being less than 40. But so I guess that's the answer. But I don't get that if it's more than 1 standard deviation away. Hold on, standard deviation of 10.
I just don't. Okay, I feel like I'm feeling dumb here. I don't understand why on the preparation, well, on the answer key it says z equals -1.
That's what I was just. That's why I'm over here. I'm just looking at that.
We're
Same
doing a
thing.
probability,
What
but
it's,
I feel like that's like the z-score.
what it's saying is that the z-score, since they talk about using the 68-95% rule, it's saying that it's 1 standard deviation away. So if it's less than that, it'd be negative. The z-score would be negative.
Mm-hmm.
So they're saying -1. They're saying it's -1 standard deviations away.
Okay.
But I don't get why it would be, because the standard deviation is 10. So unless they're splitting that one in half. See, I thought standard deviation meant 10 either way, so I thought it meant 35 up to 55.
Yeah.
But this, in this one, it's saying 40 to 50.
Wait, where are you getting 50 from?
Because what number 6 is saying is that 40 is 1 full standard deviation away from the mean of 45. But it says the standard deviation is 10. So what I'm saying is I understood the standard deviation to be beneath, one fold beneath, and one fold above. So with 45, how that one standard deviation meant it would be within 35 to 55.
Okay.
But this is saying that it's from 40 to 50 because the standard deviation of 40 is -1, meaning it's one full standard deviation away from the mean. Does that make sense?
Yeah, a little bit.
Well, I want to make sure you understand it. Maybe I should just make sure that's what... I think that's wrong. I think that, unless I'm understanding it wrong, 'cause I even Googled it and it says -1 full standard deviation. But that's what this is saying. All right. Anybody confused?
I mean,
What?
7. Sorry,
You're good.
I was just saying that 7 on the answer key. It makes sense to me because it's saying that that's 2 standard deviations, and that's in the 95% probability.
Yeah.
But what doesn't make sense to me is number 6 on the answer key. It says like -1, so I'm assuming that's like the standard deviation.
I think number 6, they just made an error.
Okay, because
I think they meant to put 35.
okay.
Because yeah, number 7 clarifies it that a standard deviation.
Yeah, number 7 on the answer key makes way more sense than...
Wait. No, see, number 7 is saying the same thing. That's not making sense to me.
Isn't number 7 saying exactly what you were saying, though?
No, because what I'm saying, if you go on the 68, 95, 99.7 rule, if you Google that or something,
Yeah.
it says one standard deviation goes negative both ways. So what this, I guess that's what I'm confused about, is because this is saying that a standard deviation is divided in half for it to go both ways, because the standard deviation is for this is 10. Right? Am I reading that right on the top?
Yeah, that's right.
Yeah.
So one standard deviation, one negative going below it should be 35.
Mhm.
One going above it should be 55.
Yeah.
Right.
So that would make number 7 just 68, because that should just be one standard deviation away.
True.
Okay.
But this one's saying it's 2, which in my mind is saying that they're saying that the standard deviation of 10 is meaning 5 above and 5 below. So it's divided in half.
Yeah. Okay, yeah, I see what you're saying. So 6 does make sense to me now, but 7 doesn't.
Well, it makes sense if you're saying the standard deviation is divided in half.
Yeah. But did they say that it was divided in half?
And that's what I don't, it shouldn't be. Am I, unless I'm missing something. See, the number 25 confuses me, or number 8 confuses me too.
How did you get 25?
Because it says 25 in the problem.
Oh.
Okay, but maybe,
Okay. So
I think maybe we're not supposed to be just using that.
for number 8, I think I have it.
See, I think what I'm doing wrong is that it's supposed to be, we're supposed to be doing it under a normal distribution.
Yeah.
Okay.
Well, the thing is that if you plug everything into that equation that they gave us, the z equals the x minus m over standard deviation. If you do the 41 minus 45, which was the mean, over the standard deviation, which is 10, divided by the 25, well, the square root of 25, it all comes out to be negative 1.5. And I'm guessing you could round up.
Hold on. Sample size. So the sample size is 4. Standard deviation is 10, right?
Mm-hmm. Because then if you do the thing for the 49, if you plug that into the equation, then you do get 2. Why is this so confusing?
Okay, what did you just see? Say that again.
Okay, so that equation that they gave us up at the top, like number 2,
2. Yeah.
if you plug everything into that, the x, you can put for 8, you can put 41, and
Mm-hmm.
you subtract the 45 divided by 10 divided by the square root of 25, which is 5. And if you do that, it comes out to negative 1.5. But then when you do that and substitute the 49 in,
How
you
does
get
it come to negative 1.5? It should come out to negative 2 because 41 minus 45 would be negative
Oh
4.
yeah, sorry. It's been a long
So
day.
that one makes sense to me then.
So I think we're supposed to do that.
Yeah, you are. I was overthinking it. So, but for number 6 though, so you go 40 minus 45. I don't have a very good calculator. I have to have my phone. Um, so 40 minus 45 divided by 10 over the square root of 4. What does that come out to?
40 minus 45 divided by,
Is that a negative 1?
what'd you say? 10 over the square root of 4?
Yeah,
Mm-hmm.
it came out to negative 1.
Yeah.
Okay.
Oh,
Okay.
it's all making sense now.
Life goes on.
Okay, so number 7 then.
Would be 2.
Yeah. Because then you have to do the 2 separate ones.
Yeah, so you would get negative 2, and then, so 35 is negative 2, and 55 is 2.
And then I'm assuming that we just do the 68-95 rule.
Yeah. Yeah.
Oh, okay. That's weird, but that makes sense now. I was all bass backwards.
Funny.
Okay. Look at
So,
us go.
and we have 8 then, right?
Yeah.
Negative 2 and 2.
Yeah.
So the probability would be 9.9545.
Mm-hmm.
Which, okay. So, nine. Oh, am I supposed to be reading it? Sorry.
Oh, no, you're fine.
A sample of size n equals 25 is taken from a normally distributed 2011 sales data. What is the probability that the observed, what is that again?
What is the probability? That's the sample mean.
Sample mean is greater than 50.
I got 2.5.
Yeah, so we put that in the z-score.
Then how would you get the probability?
1 second. So it's greater than that?
Yeah.
Yeah.
The answer is going to be 0.0062. Because you type that in the applet, and then everything to the right of that z-score,
Oh, okay.
what it is.
Yeah.
Bam!
You guys, we're smart.
Almost. Only took us forever to figure that out. Holy cow, there's still
Yeah,
5
there's
more
still
questions.
more. Keep going. Okay. So number 10. Peer computing sold an
Peer or
average.
pair?
What?
Peer or pair?
So let's just
Oh,
stay pair.
pair.
I was just giving her a hard time.
I've been at a salon since 12:30, and I got home at like 7 o'clock. So my brain is like crushed.
I don't
You
know how
were
you do it.
No, I was getting my hair done. And it took that long.
All right, let's go.
Go, read it.
Sample size of N equals 4 taken from a right skewed 2010 P-phone sales data. What is the shape of the distribution of X?
right skewed.
Yes.
See.
Okay. Samples of size n equals 40 are taken from the right skewed 2010 pphone sales data. What is the shape of the distribution of X? I mean, of sample mean.
So we'd use this central limit, right?
I think so, because it's getting bigger.
What was the smallest size that we could have for it to still for the central was
30.
yeah, so it's gonna be approximately normal because
Normal. Yeah, almost normal.
Approximately normal. And then that answer number 12, that's the central limit theorem.
Mhm.
yes.
Okay. A sample of size n equals 4 is taken from the right skewed 2010 pphone, and you want to know the probability that the observed sample mean is less than 35. Can you compute this probability using the normal probability applet with the information you have, and why?
No.
Oh,
Because
you can't because
equal.
it's not normal, and
Yeah,
the normal probability, yeah,
we're normal.
yeah.
Okay. A sample size n equals 36 is taken from a right skewed 2010 pphone data sales data. What is the probability that the observed sample mean is greater than 36.5?
Okay, let's see. Yeah, 1.7. Well, negative.
Yeah.
Yeah, negative 1.75.
Mm-hmm.
So, hold on. So, oh, I see what I did. My bad. Okay, yeah. Yep.
Okay. 15.
Okay. The sample of size n equals 36 is taken from the right skewed 2010 pPhone sales data. What is the probability that the observed sample mean is between 37.5 and 42.5?
Okay. So.
Got negative 1.25 and 1.25.
Yep. So then the z-scores for the z-score of that it's 1.056, or excuse me, 0.1056 for both of them. So we put 1 minus 0.1056 minus 0.1056.
Okay.
That'd give us 0.788.
888.
Cool.
Oh, man.
That was fun.
It's okay, those questions only took us an hour.
It's alright.
Hey, now for the quiz.
Oh,
We
good.
understand it now.
What did you say?
So it's alright, we understand it.
Hold on, I'll be right back. Okay. Sorry.
Alright, let's not get a C on this one.
Yeah.
Alright, ready?
Yes. Yes.
Okay.
At least we know we can get 1 and 2 right.
I know.
So number 3 says use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.385 and to the left of negative 1.38 or 358. So we want the combined area of that.
Oh, okay.
358.
1.358.
Did you guys get 0.175 after you round it?
What?
What did you guys get?
How'd you get that?
You go to the normal probability applet. And you type in that z-score, and then you highlight the areas to the right and to the left of that. that what you guys got?
1 second. It's taking forever to load it. Okay, my computer won't let me load it.
Well, that's what I got.
I think you're right, Chase.
What did you get?
0.175.
Okay. We ready to move on?
Yep.
The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean, than was observed in this sample. Round your answer to 3 decimal places. As extreme or more extreme means that are not only interested in values that are lower than the ones we observed, but also values that are as far away from the mean as ours in the positive direction. So find the probability that a random sample of passengers will have a weight that is extreme or more extreme than was observed in this sample.
So we take 177.6 minus 185 divided by 26.7 divided by the square root of 48.
Mm-hmm.
Wait, say that again?
177.6 minus 185 divided by 26.7 divided by the square root of 48.
Yeah.
I don't have a very good calculator, so I need to know what that answer is.
Got negative 1.920. What I'm wondering is, it says, find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. So are they just trying to like trick us with the language and think that we have to do something else? Or
What did you say you got?
I got negative 1.920.
Okay, that's what I got too. I don't know.
Because I mean, I'm guessing that we would do just these because everyone would have a different answer.
Yeah.
Okay. Next one?
Yep.
Okay. Which of the following will have...
So,
What?
I mean, what did you just say?
I was just wondering, because it says find the probability that a random sample of passengers will have a weight that is as extreme or more extreme. It says either above or below the mean. So I was just wondering if we're just supposed to use those values for calculation or if we were supposed to come up with another. But then if we came up with another, everyone would have different answers.
Why would everyone have different?
Like everyone in the class. Because if we picked like our own number, like our weight.
Like if we put in your weight, Megan's weight, and my weight.
I know.
Like if we change the sample mean. I was just wondering if they were trying to trick us.
Find the probability that a random sample of passengers will have a weight. Yeah, I think you're right.
Okay. Next
So,
one?
what would you put as the answer is?
Negative 1.920.
That's the z-score, though. You got to put that in the applet.
Oh yeah.
Oh, yeah.
It's a good thing there are 3 members of our group.
I don't have applet up. Mine won't load.
What do you mean it won't load?
It won't load.
Have you gone to lesson 5 and clicked on it?
Yeah.
Lesson 5 or lesson?
Yeah, I keep trying to go back on the different thing, but the server won't load.
Do you have yours up though, Chase?
Yeah. So the areas to the right and to the left total 0.0549.
Point what? 0459?
No, 0.0549. But they want it in the
So that would be
three.
point 0.055. Right?
But we're doing it to 3 decimal places.
Yeah, so it's 0.055.
That's what I said.
Yeah.
Okay. Okay, which of the following will have a smaller standard deviation if 9 observations are randomly drawn from the population? The distribution of the individual operations X, the standard or the distribution of the sample means, or this cannot be determined from the information given.
I don't think that can be determined. Because we don't really know what they're observing. And we can't really tell like what the sample size will be. Because that's what it depends on.
Yeah, I think
mean, do you understand what I'm saying?
Yeah.
Yeah.
I get when I talk about individual observations, what does that even mean?
Because it
What's
says that there were um, 9 observations. Does that mean that, like, there were 9 experiments done, or?
oh 9 observations? Oh, I see.
I mean, if it was just the 9 observations, the sample mean is the same as the population mean. Oh, so would the individual one?
The distribution of the individual observations?
Yeah. Would that be it? Like, is it like one observation, like one set of data, or one data piece?
All I know is it seems like when the deviation has gotten smaller when we've done it from the sample means than it was.
Mm-hmm.
I almost feel like it would be number 1.
The
I
individual,
mean, number 2.
the
Ah,
distribution of the sample means?
yeah, but I'm not 100% sold on that. I could be easily swayed.
I don't know, because it usually says that the sample mean um, is the same as the population mean.
But it's just asking which will have a smaller standard deviation.
Oh, sorry. Long day.
No worries.
So the distribution of the sample means.
Yeah.
I think that
Okay. Which of the following results implies that the spread in sample mean decreases as the sample size increases? The normal distribution, the 68, 95, 99.7% rule, the central limit theorem, or the law of large numbers.
I think law of large numbers.
I agree.
Yeah.
Oh my heck. We still have so many questions.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed with mean 150.8 and standard deviation 8.8. Use this information. Yeah. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Okay, let's see. Is it 1.045? Because n would be 1, because you're just taking Diane's.
Yeah.
So then really it would be 160 minus 150.8 divided by 8.8.
Yeah. So 1.045.
Yeah.
So I'm.
What, Chase?
Hello?
Hello? What'd you say, Chase? I guess he cut out.
Oh no.
Oh, he joined it back. Hi, Chase.
Hey,
Why'd you hang up?
did my internet's freaking out. So what did you guys think the answer was?
1.045.
That's what I got too.
Okay.
Okay.
Okay, 8. What is the probability the randomly selected student will score above 160 on the quantitative portion of the GRE? So, put that in the z-score. We want the probability that's above 0.148.
Yeah. Okay. Okay, are we ready for the next one?
Yeah.
Okay. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, and 153. What is the z-score corresponding to the sample mean of these students' scores? So,
So, would you add them all together
yeah.
and divide by 5?
Mm-hmm. And then 5 would also be n.
Okay.
So I got 2.338.
For the z-score.
Yeah.
So we add
What?
60.
Chase, you broke out. Say it again.
My internet is not very good. So you added those 5 numbers up, right?
Yeah,
Mhm.
and you divide by 5.
Yeah, so you get 160, right?
Right.
Yeah.
So minus that by 150.8 is 9.2.
Yeah.
I can't get the square root stuff, so I can't get the final answer. And then
Okay,
divide
yeah.
that by
And
8.
then, yeah, you divide that by 8.8 and divide that by the square root of 5.
Okay, so and what'd you get as the answer?
2.338. And then the next question is just asking for the probability of that it's greater than their mean score.
So for 9, we
What's the
put
square root of 5? Oh, no,
2.338.
never mind. 2.338.
And then 10 is what?
It's just asking for the probability of that number, that it's like greater than their mean.
So how do we find that?
The applet.
Huh?
I think the applet.
Oh. Grace,
Oops.
can you put that in?
Working on it. So that it's greater than that,
Yeah.
0.0097.
So 0.010.
I think
No,
so.
it's to the 4 decimal points.
Oh,
Oh,
perfect. So 0097.
yeah.
Yep. Suppose the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 5. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected?
Approximately normal.
Yes.
Okay, what is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
That question's confusing my brain.
Yeah, it's rattling mine.
What is the mean of the distribution of the sample means, sampling distribution, for all possible samples of size 81? I don't understand that.
Oh, wait, no. I was just going to say, oh, we just solved for x, but no, because we need to know the z-score.
Yeah, it doesn't give us any numbers of what the. Oh, I guess we could look. Okay, so 3.5 is the mean. Standard deviation is 0.7.
I don't like this question.
Oh, man.
Oh, from the reading, it says the sample mean equals the standard deviation over the square root of n.
The standard deviation over the square root of n.
Yeah.
So would n be 81
Yeah.
and the standard deviation is 0.7?
It's 0.7.
That seems too small.
It is.
But what is the mean of the distribution?
So that would be the standard deviation, wouldn't it?
This says round it to 1 decimal spot, but the answer to that is 0.07, so if we round it, it'd be 0.1.
Yeah.
Yeah.
Oh, it's confusing. What is the mean, what is the average of the distribution of the sample means?
So is the distribution the deviation? So then it could be 0.1 if it was the standard deviation that we were talking about.
The only thing. I think it's 0.1.
Jax, stop it. Come here. I opened it. Come here.
What are you thinking, Chase?
I don't know.
What you doing? Slamming your computer?
I don't get why they give us a question like that where it says round to the nearest decimal to 1 decimal spot if they're going to give us a number that is 0.077.
Yeah, 'cause normally the example have been together.
What is the mean? See, that formula we used is that's the standard deviation of the random variable. What's the mean distribution?
Jax.
Redux.
Where's the mean?
Oh, he's just being stupid.
What's that?
I said it's open. He's just being stupid.
Let's just skip it for a second. So I'm gonna. I don't.
You're gonna what?
I just don't get it. I don't understand that. What is the mean of the distribution of the sample mean? So the sample means there's only one sample, so it's 81.
Right.
Well, that's the samples. So 81.
Let's just move on, Chase.
Okay, go on.
Okay, what is the standard deviation of the sampling distribution of the random variable sample mean? The mean of the 81 students who are selected.
What is the deviation of sample distribution?
I don't really get that one either, though.
So it says that the mean is 3.5.
Yeah.
Would you just kind of like solve for the standard deviation if you use that one equation that we just used for the other?
I think the answer for 12 that you think is 12 is 13.
Oh, that would make sense.
So that'd be the point.
But it asks for 3 decimal places.
Exactly. Because the answer is 0.0777777.
Okay.
That's exactly what the book says too. The standard deviation of the random variable is standard deviation.
Okay, so the answer for 13 is 0.077.
0.078.
Oh. Okay, sorry. Calm down. So then what's 12?
I don't know exactly. 14 says, what is the probability that the mean GPA for 81 randomly selected students will be less than 3.3?
Are we just supposed to put that in applet?
No, it's the formula.
Oh.
So would the sample mean be the same as the population mean? So would it be 3.5?
Yeah.
So then that would be number 12.
No.
Number 12, 3.5.
Yeah.
Ah.
Yeah.
We're overthinking. Watch that be wrong.
I know. So then what about 14 and 15?
What do you think the answer is?
I don't know. I don't know what equation you're talking about.
It's the equation we've been using all night.
The standard deviation over the square root of the number?
You take the value that you're given minus the mean. Divide that by the standard deviation over the square root of the numbers, or the
Wait,
sample.
stop.
So you take 3.3 minus 3.5, right?
Mm-hmm.
So that's negative 0.2.
And you divide that by 0.7 divided by the square root of 81, which is 9. That's negative 2.57.
Okay, that doesn't seem right either. That would be the z-score.
Yeah, but when you put that into the applet,
Yeah,
then
and when I did, the area to the left of that, which would be less than, is only 0.0051. But we're only 0.2 away, which is not even one standard deviation away from the mean.
mm-hmm. I mean, if you do take 81 students, that would be close. That's a large number, so it would be closer to the normal distribution. So, I mean, I could see how it would be like a 0.05 number. Or maybe I'm just trying to justify it.
So did you take 0.07 and put it into the applet, Chase?
No, but why would I?
I don't know.
Oh, no, you're thinking of the other question. With this one, we have to figure out less than 3.3. So we have to use that one problem we were using on the homework. I mean, that one equation. Is that what you were asking, Cambria?
I guess. I don't know what I'm asking.
Once you figure out 12, it's easy. I just don't know why. What 12? If it's 3.5, then that's the answer, and we can figure them out. But I just don't know. It just doesn't quite seem right.
Yeah.
But if it is, then
Wait, what was the number you got for it, Chase?
0.0051.
Okay, let's just do number 15, and I'll submit it and I'll tell you if that's right.
Well, 15 will be 0.9949 because you just reverse it. But I don't want you to have to do that.
Yeah, don't do that. Although I do think we're spending too much time on it. I don't think we need to be overthinking it this much. If we are overthinking, I don't even know.
We do need to understand it, though. We can't just...
I understand that.
But, I mean, that does make sense for it to be 3.5.
For number 15?
No, for number 11.
12.
12.
Okay.
Let's do it.
Okay, let's walk through 14 again. So it would be 3.3 minus 3.5, which would be
Negative 0.2.
No, it's negative 0.2. Yeah. 0.2.
Yeah, that's what I said.
I thought you meant 0.02.
Oh.
and then you would divide that by 0.7 divided by the square root of 81.
I get negative 0.03.
How'd you get that?
Yeah.
I don't know. Don't listen to me.
Well, what'd you put in there though? That's what we're at.
That's exactly what she just said. 3.3 minus 3.5. That divided by 0.7 divided by the square root of 81.
Mm-hmm.
See, and that time it pulled up to something totally different.
Is it negative 2.57?
No. How are we getting different answers?
We're not. That's it. What are you getting? We're both getting negative 2.57.
Then just do that.
Okay, I'm submitting it.
Wait. So what's 14?
0.005?
0.005.
And then 15 is what?
0.995.
Okay, that's right. I submitted it. We got 94.
My bad. Sorry for making us take so long on that last one. You were right.
No, you're fine.
Wait, how did you get a 94? Because I got a 100.
Oh, I wrote a question wrong.
Oh.
That's okay.
I was like, me out of all people.
Good job, guys.
Only took us a couple hours.
Well, at least we got better than last time.
Yeah.
Sure. Okay, thanks.
See you guys.
See ya.